Okay, we got 2 packets today. First one, I want to recap some things we did last week. There's no assigned problems in this. We're just going through it. Okay, factor the expression. That means get that into as many parentheses as humanly possible. Put the implied 1, you got 3 terms. So GCF, table. Okay, GCF's 1. The last term doesn't have x, so we don't put x, and it's just 1, so ditch it. Now I take a times c. I'll be taking 1 times negative 64. Well, that's negative 64. So we need a positive times a negative, and we have to add the factors to get to the negative 12. Now, before I worry about finding the factors, we're going to set up our parentheses. My a is a 1, so I just need 2 of them. But my x is to the 4th, so instead of writing xx, we go x second and x second. Okay, now I'll find the numbers. 1 and 64, that doesn't even come close to adding to negative 12. Okay, if you divide by 3, you get or 2, you get 32. That's not even close. 64 divided by 3 is a decimal. 64 divided by 4 is 16. Bam, that's negative 12. So I put plus 4 minus 16. Now, because those still have even powers, we need to actually take them up here and see if we can factor the 2 binomials as adopts, difference of perfect squares. I'm going for difference of perfect squares. Now, x to the second's a perfect square, x by x, and 4 is 2. But there's a plus, so we got to put I in the back end of the parentheses. Okay? So it's x2, x2. Now over here, you got x times x, 4 times 4, and it's a minus, so I don't put I. That's a normal DOPS, like from Algebra 1 with me. 4, 4. Now those are all your factors. Just line up the parentheses. And in the front, we put our GCF, but I did absolutely nothing with it. Okay, next one, we got x to the 4th minus 64. Put the implied 1, but there's only 2 terms, so now I'm looking at the GCF, and then I go right to the difference of perfect squares. GCF would be 1, and the last term, there's a constant in there, doesn't have it. Now the DOPS, when doing a DOPS, I would ignore the 1. I'd just get rid of it. X to the 4th, it would be x to the 2nd times x to the 2nd. It is not x times x. 64 is up on the board. That's 8, so it's 8 times 8. So we have x to the 2nd, x to the 2nd, and then 8 and 8. Now, we still have even powers on the x's, so we have to possibly consider breaking them down even more. Okay, x squared is x, again, I'll set up the parentheses. Remember, that's here and that's there. X times x, 8 is not a perfect square, so forget it, okay? So I just drop those down. We have x to the 2nd plus 8, x to the 2nd minus 8. Okay, moving right along. Now I want you to review your basic properties of exponents. You have the same base. In a multiplication, we add 2 and 3. 2 plus 3 is 5. Then 3 to the 5th on the calculator, 3 caret 5 is 243. Okay, now I'm dividing common bases. By the way, up here, don't take 3 times 3. No, okay, it doesn't work that way. Now, if multiplication results in me adding the powers, division probably is me subtracting. And that's 3 to the 2nd, and that's 9. Now here you got a power to a power, so you distribute the outside power to the inside power, and that means you multiply, and that's 3 to the 6th. So 3 to the power of 6 is 729. Now a negative exponent gets reciprocated. I put a 1 over it and make the negative 3 exponent positive, and that's 1 over 27. 1/27. Now, I want you to use the properties to simplify some more complex expressions. I will be underlining that and making 3 lines. Base numbers, you got 3 and 2. Start with those and then worry about your letters. You have a D. Just write it once. Now, 3 would be to the 1 power, but since it's in parentheses, we have to distribute 3 to 1, and that's to the 3rd power. 2 is to the 1, not in a parentheses, so I just use the 1st power on my 2. D, you have 2 of them, okay? And they're on the same side of the line on top, so I'm going to be adding them right here. So 2 times 3 is 6, and then you have 2. 6 plus 2 is 8. Now, are any of those powers negative? No, not a single one. Now I figure out 3 to the 3rd. Okay, it's 27, but for those of you who are not good at that in your head, okay, 27. 2 to the 1st is 2, and then times D to the 8th. Now remember to multiply those, and it's 54. Okay, now in the next one, underline the expression. You have a base of 3 and a base of x. They're both to the 1st power, but they're both in parentheses, so we have to distribute the negative 4 to each one, so that's going to be negative 4, okay? Now, do we have negative exponents? Sure. So we need to move the 3 and the x both into the denominator and put a 1 over it, so the 4's become positive. So 3 to the 4th then is 81. It's not 12, okay? So it's 81 times x to the power of 4. Okay, next one. The line's already there, and I don't have any number bases. I have a base x on top, and then I have more base x's on the bottom. Just have it on top to start with. Now, when the base crosses the dividing line, you need to put x equals, and then it's top minus bottom. Okay? So the x on the top, you just have the negative 2. Then on bottom, you have 2 of them. You're going to take 3 and plus 2. But that's 5. And negative 2 minus 5 is negative 7. So it's to the power of negative 7. Now that's a negative, so it moves downstairs where the negative 7 goes positive. We put a 1 over it. Okay? Now, x to the 7th can't be carroted. It can't be simplified, so that's 1 over x to the 7th. Now, my next one. On top, we got a base of 2, then the variables e and g. I don't worry about the exponents yet. Now, on bottom, I have e, but I already wrote that on top, and I have g, but I already wrote that on top. So 2e and g are the bases. Now 2 is relatively easy. It's to the 1, and I distribute 1 to negative 4, and that's negative 4. Now the e, there's 2 of them, but unfortunately they cross the line, so we have to do our top. E equals the top minus the bottom. So the e on top, 1 times negative 4 is negative 4. Okay? The e on bottom is to the 5th. So I take negative 4 minus 5, which is negative 9. So e ends up to the negative 9th power. Now the g. Again, you have to use this because you're crossing the dividing line. Top minus bottom. And you got 5 minus, not 3. Those of you that put 2, that's wrong. It's 5 minus negative 3. 5 minus negative 3 is the same as 5 plus 3. That would be 8, so it's g to the 8th. So look at your powers. Got some negatives, don't you? So 2 goes to the bottom, so that becomes positive 4. The E goes to the bottom, that becomes 9. The G we don't move because I want it to be a positive power, okay? And I don't need to put a 1 on top because there's a G there already, okay? The G kicks the 1 out. So 2 to the 4th is 16. So you get G to the 8th and then 16, E to the 9th. Okay, now identifying end behaviors of functions. First off, make sure your exponents are in order. You got 7, 6, and nothing. That's in order. Now, set up for you. The leading coefficient, lead, is -8. So that means as x goes to positive infinity out this way on the graph, your graph is going to drop. Now, you identify the degree. The degree is the highest power, it's 7. That's odd. Odd means the end behaviors are opposite. So you got negative, that's going to be positive. Okay. Now, rewrite this. This is all out of order. So that needs, the highest power comes first. What's the next highest power? Third. Now I don't have power, so I put minus 4x, and then the 1's positive, so it's plus 1. Okay, lead. In the lead we have -15. That means that's negative infinity. The degree is 6. That's even, okay? Even means the end behaviors are the same, so negative infinity. Okay, this is in good order. In the lead, you have a 1. It's positive, so that'll be positive infinity there. The degree is a third power, which is odd, so they'll be the opposite. Odd opposite. Think of it like that. Okay, in the lead here, we have 1. Okay. So that's positive. It's positive 1. The degree is 4. That's even. Okay. So even means they have to be the same end behavior, the graph on each end. Okay. Now put that away, and now you're going to just practice one thing in this video. Put a second. That 7 is supposed to be x squared. And you're going to factor that into simplest form, but I've never had to factor 4 terms yet in the class, okay? 4 terms, don't worry about the GCF. I don't make any 4-term ones with the GCF. It's just going to be 1 anyway, okay? 1, 7, 9, 63, and then you got 63 without an x, so no. You're going to write the phrase grouping. And what you're going to do in grouping, you set it up. You're going to set up a parentheses plus a parentheses, then a line parenthesis, then the same thing with little lines outside for factoring out. And then you're going to make a line with a parentheses, and on that line you're going to put a teeny bitty parentheses. Big parentheses, little parentheses. Okay, and that's how grouping's set up. You're going to set all the problems up today like this. First step's easy. You just put your 1x to the third with your 7x to the second. In the second one, you're going to put your -9x with your minus 63. Now you're going to underline these right here first. And find the greatest common factor you can divide by. 1 and 7 are just in the first row, but I'm going to put 1 down because they both have x's, so I take the x second from the end. It's not just x, it's x second. Now I go over here. 9 and 63, that's where you might want your chart for, are both in the 9th row together, okay? So it's 9. I will not be dividing by x here because that number at the end doesn't have x. So don't put an x down there. Now, the leading number here is negative, so we have to make our 9 negative. That's a rule. Now, whatever I'm dividing by, I put out here. See those? I'm going to place that out here. See those? I'm going to place that out there. Now, this and this should wind up being the same. So if I divide 1 by 1, that's 1. Now, here's how you divide an x third by an x second. You get rid of the x second and subtract 2. 3 minus 2 is 1. But we don't put first powers on x's, it's just x. 7 divided by 1 is 7, and these are the same power, so get rid of them. And over here, it's going to be 1x, and that divided by that is plus 7. So did these end up the same? These two parentheses? Yes, they did. That's what you put then in the little parentheses. And after you put that in there, you're going to get rid of these. And in the big parentheses, you're going to now formulate that and that together. These now join up. So you have 1x to the second, and don't put plus negative, just put minus 9. Now, you're just about there. This didn't have an even exponent, so I just transfer that over here. That's in my answer. That is one of the factors. But this one here, I take up here to analyze for a possible DOPS. A lot of times it is. Get the 1 out of there. X times x, 3 times 3. We have a minus, so no I. X, 3, 3. Drop those down. X plus 3, x minus 3. And I have successfully factored the 4 terms like that. Okay, next problem. Again, 4 terms. GCF isn't even worth looking at on this assignment. They're all 1s. So now set up those with a plus sign. Then the same thing, you just put little spaces outside your parentheses. Then a parentheses with a space outside, and I put just a tiny parentheses right next to it. So grouping, you're going to have 1x to the third minus 2x second, and then negative 16x plus 32. 1 and 2 have as a 1. Now you got x and x, you take the end x, the power on that. Okay, 16 and 32. Now it's important you go down as far as you can. That's the furthest road down, 16. You use 8, you use 4, you use 2, you're not going to get this to work. It's got to be the lowest one down. Now, we're not doing x because we got that constant at the end without an x. So we have a negative here, so we're going to have to divide by negative. So, whatever I'm dividing by here, put that here. Whatever I'm dividing by here goes to the outside here. So 1 divided by 1 is 1. Now to divide an x third by an x second, get rid of the x second, and then take 2 away from 3. That's 1, which means it's just x without a power. Minus 2, and these you just get rid of. They're the same. And that's 1, x, and that's negative 2, so minus 2. What do you know? We have the equivalent expressions in there. So that goes in the little parentheses, okay? Cross it out then. And then I have 1x to the second, and then minus 16. Now the one without the even power goes over here. That's done, okay? Now this other one I need to transfer over here to check it for a difference of perfect squares, okay? Get the 1 out. Having a 1 in front of the x doing perfect squares annoys me. So it's just x times x, 4 times 4. So it is perfect squares. We have minus, so I don't use I. X, 4, 4. Okay, so that's x plus 4, x minus 4. Bingo. Okay, next problem. x to the third plus 4x to the second minus 9x minus 36. Grouping. Okay. Parentheses. And you're not going to notice on grouping I don't make box. I don't want to limit my workspace. Okay. I want these nice and big. Okay. By the way, if there was a GCF, you'd just divide it out, put it down here in front of the parentheses, but I didn't do that. Now you make one parentheses with a line outside, and we put a little teeny parentheses. And between these is a multiplication sign, by the way, if you're wondering about that. So grouping, you got 1x to the third plus 4x to the second. Then you have negative 9x minus 36. Now, what's the highest factor I can divide these by? 1 and 4 would just be 1. But you got x third and x second, so we need to take the one at the end. And if you're wondering, do I divide by x third or x second? Take the smaller one. You can only divide by the smaller one, because if you divide by a bigger one, you're going to end up with a negative exponent mess. x2, x2. Okay, 9 and 36. Okay, there they are in the 9th row. Don't do x in that one, because that does not have x. The negative, okay. So 1x second goes out, and then I factor out negative 9. So it's going to be 1. Remember, to divide an x third by an x second, you get rid of the x second, and then subtract 2 from 3, which is 1. But just put x. Nobody puts an x to the 1. Plus 4. Get rid of those, okay? And over here, 1x plus 4. Looking on those sides, Shazam, they're the same. So 1x plus 4. And then you combine those in the same parentheses. 1x to the second minus 9. Now this one does not have the second an even power, so that is dead. Okay, that's one of my factors. But this one here, I check that over again with those even powers. You got to constantly be checking them for dots. Okay. Okay, get the 1 out. That's x times x. That's 3 times 3. So I don't need the I because it's a minus. So x, 3, 3. So I go x plus 3, x minus 3. Boom. Okay. Last one I'm going to do in this video. Okay. And I want you to cross that problem out, and I want to make up a new problem, please. Okay. Just trust me on this one. Just trust me. Okay. I want you to put 3x to the third minus, let's go with 9x to the second. We're going to go with minus, let's see something here, okay, minus 16x, okay, plus 48. I want to make this a little bit harder so it prepares you. So, GCF still 1. These 4 numbers do not all appear in the same. Or actually, hold on a second. Gosh darn it. No, they do not all appear in the same row. Thank you. Okay, so grouping. So that means a GCF. I didn't want to put one where they actually had a GCF. Same thing, okay? That, then you copy it, you just put little lines outside. Then line, 1 parentheses, in that line I put a little teeny parentheses. So you put 3x to the third with the minus 9x to the second. Then you're going to put the negative 16x with the plus 48. Okay, 3 and 9 actually do appear in a row. They'd be 3. Not only that, you're taking x to the second with it, okay? You take the x that's at the end, the power that's at the end. Okay, 16 and 48. Now let's go look at 16. Oh, 48, there you are, okay? So I'm going to be 16, not x. 48 doesn't have x, okay? That's a constant. You can't be factoring x's out when there's a constant in there. But you do need to make that negative all day. Because if that leading number's negative, I need a negative down there to match it. So I'm going to factor out 3x this second, and I'm going to factor out negative 16. So 3 divided by 3 is 1. See ya, minus 2 to the top. So that would be x, don't put the first, minus 3, and those go bye-bye. Now hopefully I can match it over here when I divide. 1x, that divided by that's minus 3. Okay? Now look at the parentheses match, we're good. So 1x minus 3. Then I put those together, then they form a new expression. 3x to the second minus 16. Now that is prime. You don't go any further with that because it's not even x. The x has no even power. We better take a look at this one. I think some of you can tell right away this ain't going to work because 3 ain't on the board, okay? So it ain't on the board, see ya. We'll just bring that over then. Boom. 1x minus 3, 3x squared minus 16. It can't be factored into any more parentheses. Get those out of here, okay? And you should be good to go. Good.